All right, this is quiz number 2 for Physics 151, spring 2013. Emily de Châtelet, she was the one that showed that the kinetic energy is proportional to the velocity squared, so that's A. These other things, a body at rest tends to stay at rest, that was Newton. F equals ma, that was Newton. And D is just not true, so nobody ever said that. Which of these is true for thermal energy? Okay, it often rises because of friction between two substances. That's true, like rubbing your hands together heats them up. It's proportional to the temperature of the material. That's true. The temperature is a measure of the thermal energy. And it is associated with random kinetic energy of the particles in the material. That's also true. So when you heat up a material, the atoms within the material move faster. So the answer is D for number 2. BMR is basal metabolic rate. You throw a ball with a mass of 2 kilograms up with a speed of 10 meters per second. You throw it up, goes up, comes back down. We want to know what is this height. Right, at the top, it only has kinetic energy. At the top, it only has potential energy. So you say that kinetic energy equals the potential energy. That's 1/2 mv squared equals mgh. The masses cancel. I'm looking for h. So I divide both sides through by g. And I get h is 1/2 of v squared. That was 10 meters per second. Squared divided by 10. So that's a half of 100 is 50 divided by 10 is 5 meters. So A is number 4. You throw a ball up in the air, which of these statements best describes the energy of the ball at the top of the trajectory? All right, we just said this, but at the top, the kinetic energy is 0, and it only has potential energy. So A is the right answer. A closed system is where no energy goes in or out of the system. That's D. Use 200 kilocalories while climbing a mountain in Nepal. How many grams of carrots will you need to eat? Okay, let me pull up the equation sheet. I don't have it in front of me. You said to use the equation sheet to convert 200 kilocalories. Let's see, I'll run write this while we're waiting. 200 kilocalories. And then you're going to divide that by the number of calories per gram for carrots. I think it was 0.04. All right, for carrots, do I have this? Oh, here we go. The caloric content for carrots is 0.4 kilocalories per gram. 0.4 kilocalories per gram. So we just divide this by 0.4. Kilocalories cancel. 200 divided by 0.4 should be 500. Yes, 500 grams. You have to eat a half a kilogram of carrots. That's a heck of a lot of carrots. 500 grams. So that is B for number 7. While your body is resting, which of these organs uses the most amount of energy? So again, you just have to look at this table. Energy consumption rate. Here we go. This is the power ratings for your various organs. Let's see it. They're listed in order. Brain, liver, brain, skeletal muscles, kidney, and heart. I don't think the liver was one of the options. So, yeah, it's brain. Among these that are listed, brain uses the most amount of energy per unit time. Newton's first law is a description of which of these properties? Newton's first law is the law of inertia. It describes the inertia of objects. That is, that objects with inertia tend to keep doing what they're doing. If they're at rest, they tend to stay at rest. If they're in motion, they tend to stay in motion. The car lurches forward. That's because you're changing from kinetic friction to static friction, and the static frictional force is larger than the kinetic frictional force. What net force must be exerted on a 10 kilogram object to cause it to have an acceleration of 2 meters per second squared? What F is equal to m times a, that's Newton's second law, 10 kilograms times 2 meters per second squared equals 20 newtons. So the answer for number 11 is D. An apple has a weight of 1 newton. What is its mass in kilograms? What F is equal to m times a. 1 newton is equal to the mass times 10 meters per second squared. That's the acceleration due to gravity. So m is 0.1 kilograms. So that is A for number 12. Number 13, you're supposed to add up these vectors. I write vector A like this, vector B like this, and then the sum of those two vectors looks like this. This is A plus B. That will be D for number 13. What frictional force does a 100 kilogram person experience when ice skating? And this is the kinetic frictional force. It is equal to mu K times the normal force. The normal force is equal to the weight of the person. And we can look up our mu K. It's on that table. We're looking for steel on ice. Steel on ice, the kinetic frictional force is 0.02. 0.02 times my weight, which is just the mass times gravity. That's 100 kilograms times 10 meters per second squared. It's 1,000, 0.02, 20 newtons. Yeah, 20 newtons. So B is the answer. This is a very simple traction system. A mass of 2 kilograms is used. What is the force applied to the patient's leg? All right, well, I have this force, which is equal to the weight. All right, that force provides the tension, and it's equal to the weight. And that same tension is applied to the person's leg. So it's just equal to the mass times the gravity. So that's 2 kilograms times 10 meters per second squared, which is 20 newtons. All right, so that's C is number 15. There's the answers.